यस सर, गुलाम सर स्टार्ट कर दो आप,
हाँ।
मैंने बना दिया उस।
और यहाँ एक ऑप्शन पूछ रहा है, वांट टू अलाउ एन ऐप एक्सेस टू योर गूगल डेटा, यस इट्स मी, करूँ क्या?
हाँ कर दो, नहीं तो छोड़ दो, मैंने कर दिया, वो कोई प्रॉब्लम नहीं।
अच्छा, ओके।
स्क्रीन शेयर कर दो सर और स्टार्ट कर दो आप।
हाँ, ठीक करता हूँ। हाँ, ठीक। हेलो अनुष्का, आपको दिखाई दे रहा है स्क्रीन पे क्या लिखा हुआ है?
यस सर, दिखाई दे रहा है, फंक्शन एंड रिलेशन।
ठीक है, ठीक है, ओके। सो वी आर गोइंग टू स्टार्ट today's lecture on the topic functions and relation, which is a very important chapter on your for your class 12. And functions and relation is considered as the building block of mathematics. Why? Because whole calculus depends on functions. Okay, and to understand function we must have a good knowledge of relation also. Okay, so we are going to start our today's class with relation first. Okay, so I will also keep writing some definitions, so you can also note it down for your future help or need. Whenever you need, you can take help from there. So I am starting with heading relation. Okay. In mathematics, in mathematics, a relation connects elements of two different sets. Elements of two sets in any possible way. In any possible way. You can also write some more points on relation. A relation from set A to set B. A relation from set A to set B is any set of ordered pairs. What is the meaning of ordered pairs? Means there will be a collection of two numbers, one from set A and another from set B, where a small a belongs to set A and a small b belongs to set B. In other words, we can also say it is a subset of Cartesian product. Cartesian product A क्रॉस B. ये एक वे है लिखने का, जब भी हम ऑर्डर्ड पेयर्स लिखते हैं ए कॉमा बी, मतलब एक एलिमेंट हमारा सेट सेट ए से होगा, दूसरा एलिमेंट सेट बी का होगा, दोनों को हम एक पेयर के फॉर्म में लिखते हैं जो कि कार्टेशियन प्रोडक्ट को रिप्रेजेंट करता है। ठीक है, अब इसको समझने के लिए एक छोटा सा एग्जांपल लेते हैं जिससे हमें जल्दी समझ में आ जाएगा रिलेशन करता काम कैसे करता है। टेकिंग एन स्मॉल एग्जांपल, लेट अस टेक set A containing elements 1, 2, 3 and set B containing elements 4, 5. Okay. What can be the possible relations? Possible relations are from A to B. Relation R is equal to 1. You can relate with 4. You can also relate 1 with 5. Then you can relate 2 with 4. You can also relate 2 with 5. Then 3 with 4. And then 3 with 5. These are the total possible pairs of A cross B, which is the Cartesian product. And a relation R and a relation R is always a subset of A cross B. A subset of A cross B. Okay. That is, relation can be either we can take 1, 4, 2, 4. This is also a relation, example of relation. You can also take another example of relation like 2 comma 4 is there, 2 comma 5 you have taken, 3 comma 4 you have taken. This is also an example of relation. So you can take any subset, that is, you can take out of these 6 pairs any number of pairs, and that can be considered as a relation. So this is an example of relation. I have shown you with some example to understand. Now next we are going to discuss some types of relations. Like basically there are 3 types which we are studying about relation. That is reflexive, symmetric and transitive. So let us discuss those 3 types. 3 types of relations. First, reflexive. Reflexive relation. How to understand reflexive relation? It's under its definition we can write every element is related to itself. Every element is related to itself. Okay, this is called reflexive relation. That is, A comma A belongs to real number for all small a belongs to set A. Okay. Next, we are going to discuss about next type of relation, that is symmetric relation. The symmetric relation, just write, we will write down one definition, then we will discuss it with explanation. If A comma B belongs to some relation R, then B comma A should also belong to relation R. This is the meaning of symmetric definition. R here stands for relation. For example, if there is some pair 2 comma 3 which belongs to some relation R, then 3 comma 2 should also belong to that same relation. Then such kind of relations will be considered as symmetric relation. Now third type is transitive relation. Under transitive relation, if A comma B belongs to some relation R and B comma C also belongs to some relation R, then A comma C should also belongs to relation R. This is called a transitive relation. Let us take an example on these three types. Example. Let A equal to 1 comma 2 comma 3. Okay, this is a set. First one, for reflexive relation, for reflexive relation, R is equal to 1 comma 1, then 2 comma 2, and then 3 comma 3. So this is, since in set A we have three different elements 1, 2 and 3, for reflexive relation the pair should contain the same elements in both the positions, that is 1, 1, 2, 2, 3, 3. So this will be considered as a reflexive relation. Next, if we talk about symmetric relation, it can be considered as, suppose you have 2 comma 3, then its reciprocal, that is 3 comma 2, should also be present there. So this is a example of symmetric relation. Similarly, if we talk about transitive relation, so we can take this example. If we have 1 comma 2 is there, then 2 comma 3 is also a part of the condition satisfying transitive relation 1 2 2 3, then 1 comma 3 must be there, then it will be considered as a transitive relation. Okay, I've given you one example. There can be more examples based on the same set A 1 2 3. I've given you one example to just understand how reflexive symmetric transitive relations can be defined. So after this we are moving to definition of relation, or let me check if the more points we can discuss in relation. Okay, what is domain, codomain and range? That also we can discuss here. Just write down the heading, students. Domain, codomain and range. Okay, so if we want to discuss about the definition of each of these terms, let's see. Domain. In short, we can say that first elements of ordered pair. First element of ordered pair is called the domain. Second, if we want to discuss about codomain, then we can say that second element of the ordered pairs is called codomain. Then if we talk about range can be discussed as the actual outputs in the codomain. Actual output values in the codomain. Okay. Note, write down one note. Range is a subset of codomain. Range is a subset of codomain. Okay. Now, I will give you one example to make you understand. Suppose we have a example. Let R be equal to 1, 3, 1, 4, and 2, 5. So here, can you tell me what can be the domain values? By seeing the example of relation at above, domain is always the first element of each ordered pair, like 1 and 2. Also, you cannot repeat the same digit twice. So 1 will be written only once. If you have to write about codomain, so codomain will be equal to 3, 4, 5. And if you want to write about range, that is also 3, 4, 5. In this case, range and codomain are equal. So range is a subset of codomain. Okay, this satisfies the above definition. Now, we are going to discuss about functions now. So these all are for relations. So we will be moving to our next topic, functions. What are functions and how function is related with relations? Why is it necessary to study about relation first in order to understand functions? So there is a deep connection between relation and functions. So in order to understand functions clearly, you must have a good idea of relations first. So if you see under the definition of definition, a function f from set A to set B, from set A to set B is a relation where every element of A has one and only one, has one and only one image in B. ठीक है? So this is one of the definition of function. In short, 2 points. In short, definition of function can be concluded can be concluded in 2 main points. In short, definition of function can be concluded in two main points. Number one, no element of A is left unmapped and second one, no element of A goes to two different elements in B. No element of A goes to two different elements in B. Now, let us take an example to understand the definition of functions more clearly. Example. Let A equal to 1, 2, and 3. B is equal to 4, 5. Okay. Taking an example of function with pairs 1, 4, 2, 4, and 3, 5. Okay. This is an example of function. This is an example of function as 1, 2, 3 appears only once, exactly once. Appears exactly once. Okay. Now, this is one of the example. Taking another example, let us check whether it is satisfying the definition of functions or not. We have 1, 4. Then we have 2, 4. And then we have 1, 5. Can we consider it as a function, example of function? No. This is the function, Java function G does not. G does not. G does not satisfy the definition by function as one is mapped to 4, 4 and 5. Fine. we can understand, we can also understand the above two examples with the help of mapping. The help of 2 example we had taken earlier for function f, 1 comma 4, 2 comma 4, 3 comma 5. One, 2, 3, 4, 5. 1 is related with 4, is related with 4, 3 is related with 5. Function f. It is a function. Next one, second example we had taken. G is equal to 1, 4, 1, 5, 2, 4. Okay. Two, 2, 4, 5. So, not a function. Function. Why? Because one earlier we had already discussed the reason why. Because 1 is mapped to both 4 and 5. It it is against the definition of function which we had discussed earlier. Okay. Okay. Now we are going to discuss the differences between relation and function here. Okay. So let's see. Our heading is differentiate relations versus first point. Definition. Under definition, what is the difference between both? For relation, suppose here we are taking, okay, let us make a small table. Aspects, relations, functions. Under aspect, we will discuss about definition first. Definition. Any subset of A cross B. A cross B is the Cartesian product between the two sets A and B. What is the definition of a function? A relation. Function is a type of relation with exactly one output for each input. Okay? With exactly one output for each input in A. This is second type. Second aspect which we are going to discuss between relation and function is inputs allowed. Inputs allowed. Under relation, some elements of A may be missing. It can be there, no issue. But in function, it is not possible. In functions, every element of A must appear. Number third, which we are going to discuss is outputs per input. Outputs per input. It may be 0, it may be 1, or many possible outputs, or many possible outputs. But in functions, exactly one output per input. In functions, exactly one output per input is possible. Okay. Now, taking some examples, one small example, you can see 1 comma 4, 1 comma 5, 2 comma 4 on A equal to 1 comma 2. On A 1 comma 2 and B equal to 4 comma 5. Similarly, if you want to see some example on functions, we can take 1 comma 4, 2 comma 4 on A 1 comma 2 and B equal to 4 comma 5. Okay. So these are 4 points which can be used to understand functions and relations clearly. Written all those 4 points. Okay. Now we are going to discuss about types of functions here. Okay. In short, function can be stated as a function is a special relation. A function is a special relation. Then each element of the domain has exactly one image in the codomain. No elements of the domain is left unmapped. It is written as function is written as f is such that A is related with B, like this, where A is the domain and B is the codomain. Okay. Now, types of functions. Number one, or one function. Its another name is injective. One function is also named as injective. Injective. Different inputs different outputs. Different inputs has different outputs. Number two is many one. Has same output. This is called many one. Next, third type is onto function. Another name for onto is surjective. Every element of codomain under onto we can write every element of codomain has a free image. Into function. Some element of codomain then next bijective. Bijective function. A function which is one and onto is called bijective function. Okay, fine. In the slide also you can see that we have used the mapping method to make you understand how function can be represented. First diagram, it shows a function because each element is connected with one element of codomain. And second mapping is not a function as one element of domain is connected with two element of codomain. Therefore, it is not a function. Now, we will be discussing some special functions also. Okay, special functions. Some special functions. Identity function. Identity function is represented as f of x equal to x. Okay, if you want to see it graphically, okay, ये जो हमारा फंक्शन है 45 डिग्री से पास होता है और इसी लाइन को कहा जाता है एफ ऑफ एक्स इक्वल टू सी, जिसको आइडेंटिटी फंक्शन के नाम से हम जानते हैं। ओके, आइडेंटिटी फंक्शन डोमेन, अगर आपको इसका पूछा जाएगा ऑल रियल वैल्यूज, रेंज पूछा जाएगा ऑल रियल वैल्यूज, इसका स्लोप पूछा जाएगा, इंक्लिनेशन अगर पूछा जाएगा पहले 45 डिग्री, अगर आपको स्लोप पूछा जाएगा tan 45, tan थीटा होता है, tan थीटा इक्वल टू tan 45 इक्वल टू 1 हो गया। नेक्स्ट टाइप कांस्टेंट फंक्शन नंबर 2। कांस्टेंट फंक्शन f of x इक्वल टू c। ग्राफिकली अगर हम इसको ग्राफिकली देखने की कोशिश करेंगे तो ये कैसा होगा, जैसे कि आप देख पा रहे हैं ये हमारा एक्स एक्सिस है, ये हमारा वाई एक्सिस है, ये ओरिजिन। सी, यही मेरा जो फंक्शन है कांस्टेंट फंक्शन है f of x इक्वल टू सी। अब इसका अगर मेरे को डोमेन लिखना है तो कैसे लिखूंगा, ऑल रियल वैल्यूज। अगर आपको रेंज पूछा जाएगा तो सी, हर बार इसका रेंज सी ही आएगा। अगर इसका इंक्लिनेशन पूछा जाएगा तो मतलब एक्स एक्सिस के साथ कितना एंगल बना रहा है, 0 डिग्री। फिर इसका अगर स्लोप पूछा जाएगा तो कितना बताएंगे हम, tan 0 डिग्री, दैट इज 0। थर्ड, तीसरा टाइप कौन सा है हमारा, पॉलिनोमियल फंक्शन। पॉलिनोमियल फंक्शन कैसा होता है, f of x इज इक्वल टू ax टू द पावर n प्लस bx टू द पावर n माइनस 1 प्लस डॉट 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 चलता रहता है। तो पॉलिनोमियल फंक्शन के अलग अलग डिग्रीज हो सकते हैं, डिग्री 1, डिग्री 2, डिग्री 3, डिग्री 4, है ना। तो 1 डिग्री पॉलिनोमियल अगर आपके पास है polynomial linear linear फंक्शन। अगर आपको 2 डिग्री पॉलिनोमियल लिखना है तो क्वाड्रेटिक फंक्शन। तो 3 डिग्री लिखना है पॉलिनोमियल 3 डिग्री जो पॉलिनोमियल होता है वो होता है हमारा क्यूबिक फंक्शन। वैसे ही बहुत सारे हो सकते हैं एंड सो ऑन। ठीक है, तो हर एक का डोमेन रेंज वेरी करेगा, वो डिपेंड करता है कितने डिग्री का है। तो इतना है कि डोमेन जो है हर पॉलिनोमियल फंक्शन का ऑल रियल वैल्यूज होगा, लेकिन रेंज जो है आपका वेरी करेगा। ठीक है। हम्म तो डोमेन रेंज की बात हम इस पे नहीं कर पाएंगे क्योंकि एग्जैक्ट फंक्शन देना पड़ेगा उसे, डिग्री 2 है, डिग्री 1 है, डिग्री 3, फिर हम उसके अकॉर्डिंग ही डोमेन रेंज की बात करेंगे। ठीक है। तो चौथा फंक्शन हम यहाँ डिस्कस करेंगे अभी, वो है हमारा रेशनल फंक्शन। रैशनल फंक्शन जैसे रैशनल नंबर होता है वैसे रैशनल फंक्शन होता है। तो रैशनल फंक्शन का अगर आपको एग्जांपल देखना है तो ये ऐसे होगा, एफ ऑफ एक्स इज इक्वल टू पी ऑफ एक्स अपॉन क्यू ऑफ एक्स। ये है क्यू ऑफ एक्स शुड नॉट बी इक्वल टू 0। ये फंक्शन का एक टाइप होता है जिसमें दो फंक्शन का कॉम्बिनेशन होगा, मतलब दो पॉलिनोमियल फंक्शन का डिवीजन के फॉर्म में रैशनल फंक्शन बनता है। तो इसका भी डोमेन रेंज निकालने के लिए एग्जैक्ट वैल्यू उन्हें देना पड़ेगा, फिर हम डोमेन रेंज निकाल पाएंगे। ठीक है, आप शॉर्ट में बस लिख लो रैशनल फंक्शन rational function is a combination of two functions, right? Is a combination of two functions, is a combination of two functions where one function divides the other. Clear? Okay. What more types we have? What is inverse of a function? Write down next heading. Inverse of a function. Okay. Inverse of a function exists only if the function is bijective. Function is bijective. Also, you can write f inverse of f of x equal to is equal to x. Okay. Now, what is composition of functions? Means we are going to combine two or more functions together, which is called as composition of functions. It is written as f of g of x is equal to f of g of x. Also, f of g is not equal to g of f, as order is important, as order is important. Okay, so these are some of the points which we discussed regarding uh, relation and functions. So these are the slides based on the same concept which we discussed. You can see it one by one. I am changing the slide. You can go through it. This is a vertical line test. This is generally used for checking whether a function, whether any given value is a function or not, right? So what we do in vertical line test, we are just drawing vertical lines for any graph which we have been provided. And if that vertical line cuts the graph in more than one point, then that is not considered as a function. Like you can see two diagrams we have drawn. First one, the vertical line is touching the graph at only one point, so it is a function. While in second graph, the vertical line is cutting the function at two different points, so it will not be considered as a function because it is going to give you two different output values, two different range value for the same domain. That's why it contradicts the definition of a function. Okay, domain and range are explained in the form of functions. A machine is there, we are providing some values, x value as domain, and the machine processes it, which is considered as the function, and gives some output which is our range value, that is y value. Okay, next you can see these are all the points which we discussed about relation and functions. Okay, these are some types of functions which we discussed. The first one is linear function, or you can also say it is a what you can say identity function. This linear function is an example of identity function and it is passing through the origin. Okay, second one is quadratic function, and this one is a modulus function. Third one, fourth one is a square root function. Fifth one is a graph of cubic function, and sixth one is a graph of exponential function. Okay, so similarly, if you go to the next slide, these are the some real world functions with examples where we are applying this concept of function in our real life. So we know that mathematics plays a very vital role in our day-to-day life. Similarly, you can say like for calculating distance, which formula is speed into time, function plays an important role. Like distance is directly proportional to speed. Similarly, whenever you are finding out some cost of some given item, so you know that per item, whatever the price they have given into number of item is going to give you the total cost. This also involves the concept of function here. Again, there is a relation between Fahrenheit and Celsius scale in the temperature, in temperature for calculating temperature and all. So here also we can apply the function concept, as we can see that Fahrenheit value will be directly proportional to the Celsius value. Okay, next, these are some examples which with the help of which they have calculated some domain and range. Whenever you will get some algebraic example like 1 upon x minus 2, the denominator should not be equal to 0, as 1 upon, as some finite value upon 0 gives you some indefinite value, one not defined value. That's why the denominator should not be equal to 0. So when you will equate it with 0, you're going to get the value of x as 2, and 2 minus 2 becomes 0. So other than 2, all the values will be the domain for this. Okay, so minus infinity to 2 and 2 to infinity. Second one, this is also a graph showing some domain and range value. You can see, you can understand it. Okay, so this you can see. Our last slide is foundation of advanced maths. Okay, how we are going to apply this concept of function in advanced mathematics. You can see some points are written there. Functions appear everywhere. Calculus studies rates of change through functions. Statistics models, these you are going to study in class 12th when application of derivatives and all is there. So there is a complete chapter of AOD. Calculus is a vast chapter. Okay, vast field. It is a vast field where a lot of chapters are included. Under this, we also get application of derivative, statistics models, probability functions, physics describes motion and forces, where we are applying forces, concept of functions and all, economic analysis, supply and demand curves, and computer science builds algorithm with function logic. These all are the advanced maths applications. Master functions now to unlock higher mathematical sophisticated real world problem solving. This foundation is essential for STEM success. Okay, I hope you can see this. Some diagram is there which is connecting some functions like dy by dx is there, integration is there, differentiation is there, summation is there. All are going to help you in you can say constructing a real world bridge. Also, economic graph, it is helpful in calculating economic graphs where we are studying about the finances and all. In constructing computer algorithm, it is very much helpful. Without maths, we cannot even imagine. Okay, for algorithms and all. Similarly, in scientific research, these higher order mathematics, that is advanced maths, this is the, you can say, the basic part, the function and relation, which are going to connect you to advanced maths and higher order mathematics and its application in real world. So that's all will be for today. Hope we'll meet again tomorrow at the same timing with new chapters. So come prepared to whatever we have discussed today. Go through it. If you find out any difficulty, any doubt, we can discuss in the next class, and we will be also simultaneously discussing some different chapters on it. So best of luck for today. Thank you all. I will be ending the class for today at here. Thank you all for being here.